Today we are going to go over 8.8 Part 1 Power Series. And in this lesson, we are going to go over radius and the interval of convergence for any given power series. So what's the definition of power series and how do we find the radius and interval of convergence for any given power series? Let's have a look at the do now problem. How do we solve absolute value function? So absolute value x minus 2 less than 8. So x minus 2 will be between negative 8 and positive 8. So we add 2. So x will be between negative 6 and 10. Let's have a look at the degree of a power series. The degree of a power series is defined by the power on the highest exponent. For example, highest power x cubed, so degree is 3. 1 plus x, degree is 1. This degree has n, degree 5. And if it's a constant, the degree is 0. So before we go over the definition of power series, let's have a look at this table. All functions include some very important functions like e to the x can be approximated using a polynomial, Taylor or Maclaurin polynomial. The polynomial itself will not exactly the same value as of the function, but can sometimes be very close to the function value. For example, e to the x, the Maclaurin series is given by this. This polynomial's approximation gets better and better when we use more terms. For example, if we want to approximate the function value at 0, so e to the 0, the original function e to the 0, which is 1. And these are the 3 different polynomial approximations: first degree, third degree, and fifth degree. So let's have a look at their value. We plug 0 in, everything equals 1. So at 0, everything is accurate. However, when x equals 1, 2, let's have a look. E to the 1, e is approximately 2.7. If we plug 1 in, we have 2, 2.6667, and 2.716. And e squared is approximately 7.389. So the approximation, if we use the first degree, give us 3, 6.33, 7.267. As we can see, as the degree of approximation is increasing, the accuracy is much better. This is the real value. This is approximation. So for this type of series, e to the x, 1 plus x to the first, x squared, x to the third, x to the fourth, x to the n, we have a very special name, which we call the power series. So the definition of power series: if x is the variable, then an infinite series in the form of a0 plus a1 to the x to the first plus a2 x squared plus a3 x cubed. Okay, and this form, which we call a power series. All the power has to be integers, and more generally, an infinite series given something like this, we replace x using x minus c. This is what we call power series 2, and centered at c. For example, this series, if we expand it, 1 plus x, x squared, x cubed, this is a power series. This one, 1 minus x plus 1 to the first, x plus 2 squared, 1 squared. This is also a power series. So center here, if you look at here, center is 0. And here, center equals negative 1. And center here equals 1. So right now in chapter 8, we learned so many different types of series. What's the difference we are learning now and the series we learned in the first part? For example, sigma n equals 0 to infinity x to the n over n factorial, this example. And the series we learned before, how do you test the convergence of 1 over n factorial? If you look at here carefully, the series we learned in part 1, there's only one variable changing n goes from 0 to infinity. And here, in power series, here, x can also be a variable. So x can be 0, give you one series, x equals 1 give you a series, and x equals 2 give you a series. So the series we learned in part 1 is when we plug x equals 1, will give us the series. So generally speaking, the power series we are talking about depends on the x value. We have different type of series. For which type of x values this power series will converge? Let's have a look. A power series in x can be viewed as a function of x. So f of x equals this, where domain of f is the set of x values for which the power series will converge. The convergence of a power series comes in one of the three flavors here, three different cases. For a power series centered at C, precisely one of the following has to be true. The series will converge only at center C. That means only x equals C, the series converges. Second case, there exists a real number R such that the series converges absolutely for this interval and diverges when this is greater than R. So this is the center C. So x has to be, the difference between x and c has to be in this interval. So x has to be c minus r and c plus r in this interval. Only this interval it will converge. And the third case, the series will converge everywhere. And the number r here is called the radius of convergence. And the series converges only at C, the radius of convergence we call r equals 0. And the series converges for all x value we call the radius of convergence r equals infinity. And the set of all values x for which power series converges is what we call the interval of convergence. There are a lot of information here. So that means if we only converge at x equals c, so x can only be there. So the radius equals 0. X cannot go anywhere. If x converges everywhere, so everywhere, so x can be anything. So the radius will be infinity. Or x minus only converges in this interval. This r is the radius of convergence. And the interval of convergence is where x is convergent. How do we find the radius of convergence for power series, which we just need to use the ratio test? So we just set the limit and go to infinity, an plus 1 over an less than 1. And keep in mind this an, we have x involved. So the general steps to find the radius of convergence and interval of convergence for any power series. First, ratio test. Second step, if the limit equals 0, we directly claim r equals infinity. That means, because 0 is always less than 1, that means the series will converge everywhere. And if the limit is infinity, as we know infinity is always greater than 1, that means it's not going to converge except the center C. Only converge at center C, r equals 0. If the limit gives you a function of x, then we set this function less than 1 and solve this for r and interval convergence. Let's have a look. How do we find the radius of convergence and interval convergence? So first step, we use the ratio. We find the ratio. Center here, c equals 0 because x to the nth power. So limit and go to infinity, an plus 1 over an. We plug a, so we replace n plus 1, n using n plus 1. So x to the n plus 1 over n factorial x to the nth power. Now we simplify it. So it's a limit and go to infinity. N plus 1 times x to the n plus 1 divided by x to the n. This is what we have. So now we only look at n go to infinity. We can treat x as a constant now. So as n go to infinity, this is infinity. As infinity, it's always greater than 1. So that means it will only converge only at x equals c, which is 0, and the radius of convergence, which is 0. That's radius of convergence, that's the interval of convergence. Only converge at 0. So you can write down this is interval convergence and the radius of convergence. Let's have a look at example 2. So first, we take the limit an plus 1 over an, which is the limit, and go to infinity. 3 times x minus 2 n plus 1 over 3 times x minus 2 to the n. 3 is cancelled. So limit and go to infinity, x minus 2 to the first. So as n go to infinity, there is no n, so this is the same as this. We set this less than 1. So from here, our radius of convergence, which is this number, r equals 1. And the interval convergence, we are going to solve this inequality. So x will be between 1 and 3. Interval convergence. However, if it's this case, in this case, you also need to check the convergence at the boundary A and B. So we get 1 and 3. We have to check when we plug x equals 1 in if the series converges. So we plug in sigma n equals 0 to infinity 3 times negative 1 to the nth power. As we know, this becomes alternating series. As n go to infinity, it's oscillating. Nth term test, this diverges. And when x equals 3, we plug it in sigma n equals 0, 3 times 3 minus 2, which is 1 to the n, which also diverges. So both n diverges. So our interval of convergence will be 1 to 3. Let's look at example 3. So first step, we have to do limit and go to infinity. An plus 1 divided by an, which is, be very, very careful here. An plus 1, we are going to replace n using n plus 1. So this will replace n plus 1. This will be 2n plus 3 divided by 2n plus 3 factorial. Divided by, we flip it, 2n plus 1 factorial over. So this is cancelled because we have absolute value. 2n plus 1, so we have 2n plus 3 times 2n plus 2 and x squared here. As n go to infinity, this will be 0. And we know 0 is always less than 1. That means this will converge for all the x values. So the radius of convergence will be r equals infinity. And the interval of convergence will be negative infinity, all values of x. Okay, we have 3 more problems. You guys can have a look and try to solve it yourself and compare with my answer key. This is the answer key for the second page. Example 1. Number 2. Don't forget to check at the 2 points. Diverges. And example 3.